ladies and gents. So this is the second part of this lesson. This is going to be a bit of a long lesson, so we will count it as a double lesson, 1 and 2. In the first lesson, we had a look at like an introduction, basically what is the difference between acid and base. Now we're going to look into more how to identify which one is acid and which one is base, because as I said, I don't really want you to start tasting, and if it's sour, it's acid, and if it's slippery, soapy, then it's base, because that can really cause damage. So what we use are a bunch of material called indicators, okay? Now, by the way, about notes, I'm not going to write down anything, but under this video, I'll give you all the notes, okay? And what you got to do is, I think the best thing is just to copy it. Okay? If you can print it and then stick it into your book, easier, but otherwise just copy it to your book. Okay? So our first indicators are litmus paper. Sorry, I should have said, what is an indicator? It's a material that helps us decide whether it's acid or base. Okay? And now I've got this is not water, this is hydrochloric acid. I kept the bottle where it came from here, so I remember. So that's hydrochloric acid. And this milky white transparency thing is basically a bicarb soda, okay? So it's a base. And we're going to start with a litmus paper. Okay, I'll write it down for you. Litmus paper, that's our first indicator. Now we have two kinds of litmus papers. We've got blue and the red. Okay? Now, let's start with the blue. Now if I put the blue inside the bicarb, inside the base, okay, you can see it's still blue. It doesn't really do anything. Okay, nothing there. Okay, but let's take another blue litmus paper, and let's dip it into the acid. Okay, straight away you can see it's red. You can see where it touched and where it isn't. So acid turns a blue litmus paper into red, but base just keeps it blue. Okay. Let's move on to the red. Okay, so we've got a red litmus paper. We have a blue and a red. A red, if we put it in acid, what do you reckon will happen? You probably guessed right. Okay, the red remains red. Okay, but if I take another red and put it in the base, what color will happen to it? I think you probably will guess. It goes blue. So that's quite cool, isn't it? Okay, litmus paper. Okay, cool. I'll pause you and move on to the next. Alright, so we're moving on to our second and third straight away indicator. And our second indicator is a blue, little Mr. Blue called bromothil blue. Okay, let's see what happens. By the way, I've poured these are two acids and these are two bases. Okay, so I'm going to start with the base here. I'm going to put one drop on here. It's bromothil blue, it's very blue color. And you can see that the blue just remained blue, so no big deal here. Let's put bromothil blue in the acid, and you can see that you get a distinctive yellow. Okay, so bromothil blue in acid turns yellow. There's kind of a common theme, isn't it? Acid is more like orangey, red, yellow, where base tends to be more blue. Okay. Now, our next friend here, saying this, if you can say that, I've got a lot of respect. Phenolphthalein, say it. Phenolphthalein. Okay, right, everything is going to be written for you, don't worry, okay? Phenolphthalein is colorless. You can see it doesn't have any color. And I'll start with the acid. This is inside acid. And if I put phenolphthalein in an acid, it remains boring, transparent, no color, okay? If I put phenolphthalein, what color? Go on, guess. What color is going to be now? It's going to be some kind of color, isn't it? Okay? Hey, I bet you got that wrong. Okay, I would have guessed wrong. You got pink. Okay, so phenolphthalein in base goes pink. Okay, so that was our number 2 and 3 indicators. Okay, we had so far litmus paper, red and blue. We had bromothil blue, and our last friend with a difficult name, phenolphthalein. Okay, let's move on to our last one. I'll just pause you here.